All right, this is going to be part 2 of the review for applied. So I'm going to pick up where I left off. I finished number 12, so let's start number 13. 13 and 14 both ask you to solve by using the quadratic formula. So I'm going to put the quadratic formula right in the middle here. Whoops. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So for question number 13, you've got a is equal to 1, b is equal to negative 4, and c is equal to negative 8. All right, that's right across because it's written in standard form. So when we do the equation here, I'm going to put this off to the side because I'm going to write some space here. I need space. The opposite of b, so the opposite of negative 4 is positive 4, plus or minus square root. We're going to do b squared, so negative 4 squared minus 4. A is 1, c is negative 8, all over 2 times 1. So 4 plus or minus negative 4 squared is 16. Negative 4, I'm doing this part right here. So negative 4 times 1 times negative 8 is going to be positive 32. And then all over 2 times 1 is 2. X is equal to 4 plus or minus the square root of, 16 plus 32 would be 48 all over 2. So let's see, I need to simplify the square root of 48. So we're going to do, 2 times 24, 8 times 3, 2 times 4, and 2 times 2. So let's see, if I collect all that fun stuff up, I've got 4 2s and a 3. So the square root of 42, square root of 48 is going to be 2 times 2 times 2 times 2 times 3. So let's see, you got a pair of 2s. That means I'm going to pull a 2 out. Another pair of 2s. I'm going to pull another 2 out. And then what didn't pair up is 3, so that's going to be 4 root 3. All right, so x is equal to 4 plus or minus 4 root 3 all over 2. And then you're going to recognize, hopefully, that 4, 4, and 2 are all divisible by 2. So x is equal to 4 divided by 2 is 2. That was at 4. And then another 4 divided by 2 is 2. So plus or minus 2 root 3. And then 2 divided by 2 is 1. I am way too lazy to write that denominator of 1. So x is equal to 2 plus or minus 2 root 3 for number 13. I'm going to slide on over to do number 14 here, which is the same kind of problem. Let's see, in this case, a is equal to 3, b is equal to positive 4, and c is equal to 6. So x is equal to the opposite of b, so negative 4, plus or minus the square root of b squared minus 4a and c all over 2 times a. So x is equal to negative 4 plus or minus, all right, 4 squared is still 16. Okay, let's see, negative 4 times 3 is going to be negative 12. Negative 12 times 6 is 72. And 2 times 3 makes 6. So negative 4 plus or minus 16 minus 72 is going to be negative 56 all over 6. So then I need to simplify a square root of negative 56. So 56 is going to get broken up into, 2 times 28. So 2 times 14, 2 times 7. And then the one thing to pay attention to is the square root of negative 1 there, because you do have a negative underneath your root there. So let's see what we got here. We've got 2 times 2 times 2 times 7. So we have a pair of 2s. So that's going to be 2, and then 2 times 7 is 14. And way back up here you had square root of negative 1. That's going to be I. So putting this all together, we've got x is equal to negative 4 plus or minus 2 root 14i all over 6. So then we've got negative 4, 2, and 6 are all divisible by 2. So x is equal to negative 2 plus or minus root 14i all over 3. Please make sure that the I is out of the root, not under it. Those are two very different things. All right, rolling right along, let's talk about graphing some inequalities here. Problem part A in 15 is a disjunction. So we've got P is greater than 2. That's going to shade to the right of 2. Or P is less than negative 3. So that means we're going to shade to the left of negative 3. And part of writing your graph is including the interval notation, please and thank you. So our shading here starts at negative infinity and stops at negative 3. So that's our first interval. And then we pick up our shading at 2 and go to infinity. So that is our second interval right there. That's a disjunction. 15 part B is a conjunction. So we have to solve this first. We're going to add 8, add 8, add 8. So negative 2 plus 8 is 6, less than 3x, which is less than 18. I'm going to divide all three parts by 3. So 2 is less than x, which is less than 6. Now I'm going to go ahead and graph it. So 2 and 6. If 2 is less than 6, then x is greater than 2. And if x is less than 6, then I'm going to shade right to the left there. And the idea here is we're going to trap x between 2 and 6, right? That is where the overlap is there. So that's going to be 2 to 6 is our interval answer for number 15 part B. Number 16, we have an absolute value equation. Absolute value, first one is easy. The absolute value is already isolated, so we're just going to drop the absolute value bars. 2x minus 3 is equal to 9. That's the other possibility here is that this expression could be a negative 9. So our other equation is going to be 2x minus 3 equals negative 9. And we're going to solve both of these. So add 3. So 2x equal to 12 and divide by 2. X is equal to 6. I'm going to add 3 to both sides. So let's see, x is equal to negative 6. Dividing both sides by 2, x also could be equal to negative 3. You got two possibilities here for the absolute value. All right. Number 17, the perimeter of a square is 48 inches. So let's take that 48 inches and divide it by the 4 sides of the square. That's going to get you, what is that going to get you? That's going to get you 12 for a side. All right. And if each side is 12, then the diameter is going to be 12, which means the radius is 6. So the shaded area here is going to be the area of the square. That's this horrible square, but that's okay. Minus the area of your circle. All right. So the area of the square is going to be side times side, or 12 times 12. Area of a circle is pi r squared. So pi, radius is 6 squared. 12 times 12 is 144. 6 squared is 36 pi. And our units here were inches squared. That is the exact answer for the area of the shaded region. Moving on over to number 8 here. A right triangle has legs of 8 and 10. So let me draw a right triangle. There's a pretty right triangle. The legs are 8 and 10. What is the length of the hypotenuse? I don't know, but we're going to figure it out. So leg squared plus leg squared equals the hypotenuse. Whoops, I use that x squared. So 100 would be 10 squared. 64 is 8 squared. If I add these together at 164 equals x squared, let's take the square root of both sides. So that's going to be x is equal to, and let's see, we've got 164 here. And I want to break this up. So let's see, 4 times 41, 2 times 2. Well, conveniently, that's where it ends, because 41 isn't going to break up in any way, shape, or form. So you got 2. That's, I don't know what that was. That's, I don't know. Okay, so 2 times 2 times 41. So we've got a pair here. So 2 root 41. Again, I don't know what I'm writing here. 2 root 41. And let me slide this on over, just so I can give myself space to put in the fact that this is supposed to be in centimeters. So number 18, the exact answer for the length of the hypotenuse is 2 root 41 centimeters. All right, number 19, normally I'd give you guys a graph. Apparently I didn't recognize that this problem was on there, so we'll do our best. Let me draw a little coordinate grid here. 2, 3, 4, 5, 6, 7. Just grid it out for myself. Good enough. Okay, so top equation here, I'm going to start off at -3 on the y-axis, and then I need to go up to 1, 2, 3, 4, 5 to the right, and I am going to use a solid boundary line, which means when I play connect the dots, I am simply going to draw a solid line straight on through there. All right, and then my shading, because it's y is less than, that is going to be shaded below my boundary line. Okay, that's the first one. Now, separately, I'm going to do this equation, y is greater than -3x plus 2. So I'm going to start off at +2. Oops, let me grab the pen back here. And then for my slope, I need to go down 1, 2, 3, and then right 1. That is a dotted boundary line. All right, there's no equal to part there, so we're going to do dotted. And then shading-wise, I need to shade above. So find your line. We're going to shade above this. And so the overlap, I'm going to grab my purple highlighter here. The overlap is this section that is shaded both red and blue. All right. So when you're solving and when you're graphing a linear system of inequalities, you're looking for that overlap position on your graph. All right. Number 20, part A and part B. Whole bunch of different ways to find these. Some of you might just be able to look at it and say, oh, it's this answer because I know it. But for least common multiple, I'm going to start listing out multiples of 6. So 6, 12, 18, 24, 30, 36, right? Just counting by 6s. And then multiples of 8 would be 8, 16, 24. And I'm going to stop right there because 24 shows up on both lists. So that's your least common multiple for 6 and 8. Greatest common factor, or GCF, for number 20 part B here. I'm going to list out factors of 18. So 1 times 18, let's see, 2 times 9, and 3 times 6 are my factors of 18. For 30, 1 times 30, 2 times 15, 3 times 10, let's see, 4 doesn't work, but 5 times 6 does. And I'm looking for the largest number, again, that shows up on both lists. 6 here, 6 here. The GCF of 18 and 30 is 6. All right, that takes us through the end of page 2. Let me see if I can do a quick simplification on problem 21 here. Following order of operations. I'm going to do 3 squared, which is 9. The negative is outside that squared part, so don't worry about that. Plus 3, absolute value, 4 minus 6 is -2. 9 to the 0 is 1. Square root of 64 is 8. So -9 plus 3, the square root of, absolute value of -2 is +2. But then this becomes a multiplication problem. All right, so then 1 minus 8. So -9 plus 6 plus 1 minus 8. So let's see. The 6 plus 1 is 7. -9 and -8 are -17. Let me actually write 17 there. So -10 should be the answer for that one. All right, I'm going to go ahead and cut the video here. I will pick up with the next problem in the next video.